The time-honored knowledge that prime numbers are indivisible is keeping us safe today. Find out how. And while you're here, subscribe to our series, The History of Math, in the YouTube channel What Makes It Tick. A prime number is a number, positive, integer, that only can be divided by 1 and itself. For example, 97 is a prime number because you cannot divide 97 by anything but 1 and itself 97. It's a very old concept, but suddenly they are fashioned again. Why? Because prime numbers are the key components of a discipline widely used today, cryptography. On networks, you want to keep information secret, and probably one of the best ways is to use combinations of prime numbers. It's funny because, again, very old theory becomes suddenly very useful. But one of the conditions to use prime numbers in cryptography is an infinity of prime number. You have to prove there is an infinity of prime numbers. And the Greeks proved it. How? Without computer. They proved by a very interesting way. It's called proof by the absurd. The starting point is exactly the opposite of the thing you want to prove. So here is how they did. Let's imagine there is a largest prime number, and we called it n. So the starting point, there is no infinity. There is a largest prime number. Now let's define P as the product of all those existing prime numbers. P is equal to 2 times 3 times 5 times 7 times 11, etc., etc. And now just add 1 to P and take P plus 1. It's a number that cannot be divided by 2. The remainder is 1. Cannot be divided by 5. The remainder is 1. Cannot be divided by 13. The remainder is 1. You cannot divide P plus 1 by any existing prime number. Okay, so there are only two possibilities. Either P plus 1 is a prime number, or P plus 1 can be divided by a prime number larger than n. But in both cases, the statement at the beginning is proved wrong. There is a prime number larger than n. So this is the absurd, and it proves that there is an infinity of prime numbers, and they can be used in cryptography. In the final episode of our series, The History of Math, we show how jumping to conclusion is the enemy of good math. Watch the full series in the YouTube channel, What Makes It Tick.